Okay, so part three, we're gonna just do one question today because I'm tired. Honestly, I'm tired. I'm hungry, and if I don't do a question now, I definitely will not do it later because it's already 8 p.m. So basically, we're just gonna do another question. You know how it goes. One I've already solved, but I honestly forgot how it works. Just to refresh my mind on things. We're still gonna tackle array questions. I'm just gonna not look at the screen. Wherever my mouse lands on, we do that question. Oops. Wherever it lands on, we do that question. Oh fuck. Okay. Wherever it lands on, we do that question. All right. Maximum subarray. Maximum subarray. I don't want to look at the solution or anything. Let me just delete everything. All right. Okay. So basically, got my trusty old pen and paper, you know, we doing out here. We know what we do out here. Let me turn the light on. All right. All right. So basically, yeah. All right. Given an integer array nums, find the contiguous subarray containing at least one number which has the largest sum and return its sum. Follow up if you have okay. Um, so we're given this array and we see 4 minus 1 and 2 1. It is 6. This actually seems similar to the question we did yesterday. It's definitely either going to be yet again a greedy or a dynamic programming solution here. So just to test, okay, we have minus 2, 1, minus 3, 4, minus 1, 2, 1, minus 5, 4. The largest contiguous subarray is right here, and the result is 6. Okay, so contiguous means obviously with a non-break-in chain. So the first thing that comes to mind is to check every possible combination, which obviously is not the solution. That would be like n fucking squared or something, maybe even n cubed. All right, so if we were to for loop through this, array, we had minus 2. All right, so if we for loop through this array, we have minus 2, 1, minus 3, 4. So basically, we just keep track. I think yet again, it's like a situation where we keep track. We keep track of the current sum. So what are we currently? What's the current max as we're looping through it? But then what's the overall max? So basically, we have like an overall max. So we can do something like, all right. So we have our. It's similar to the I guess the consecutive ones question we got yesterday. Consecutive ones, was that the question? What was the other question? I forgot what was the other question we got. It was a 2-pointer. Yeah, but no, it's kind of similar to the consecutive one question, I guess. We have a current sum. Somebody's texting me. Hang on. Who is texting me? I just noticed when you download a game, it does one at a time now, not 3. Alright, I'm gonna put that in do not disturb. I got something in the oven, so let's see if we can get this done in 20 minutes at least. Alright, current sum is 0. The maximum subarray. I think this is actually a pretty good question we landed on, but even though I'm only going to do one, because it has a lot of upvotes, but also, I think this is one of those like Facebook questions. I think I've definitely seen it. I've done the question before, but I genuinely do not remember how I solved it. So that's kind of why I'm doing these again. But anyway, current sum. Current sum is like as we're for looping through it. So minus 2 plus 1 minus 1. 1 plus minus 3 minus 2, and just keep going on and on. building up the most, the maximum. So it's a situation we have for I in range length of nums. For I in range length of nums. Well, okay, let's take the algorithm first. So if we're for looping, let's say we get to index, I don't know, index 0, 1, 2, 3, 0, 1, 2, 3, right? That's where 4 is. At this point, right? At this point, what we have is -2 plus 1 is -1, -1, -3, -4, and yeah. Then we have 0. So we're at 0 at the point where we get to 4, right? We're at 0 here. And at this point, our current max value was, the current sum at this point was 0. Yeah, the current maximum sum at this point is 0. Eventually, then we get to 4, -1, -2, and 1, which we know is 6. So we then, which is index, let me write this out, 0, 1, 2, 3, 4, 5, 6. So at index 6, which is the one over here, at index 6, we have 6 as the total sum. So our global maximum becomes 6. At this point, our current maximum is still 6, right? But then we do -5, right? -5 then becomes 1. And then 1 plus 4 is 5. So as you can see, it's kind of similar to consecutive ones. You're just kind of going through it and adding things as you go. So this is our global max equals 0. So essentially, it's a situation of current sum plus equals the current value we're at. Actually, since I'm not indexing anything, I could just pretty much say for n in nums, or for num in m's. Since I don't really need to index anything, I can just say plus num, plus num, and then at each point we just compare that to our global, right? So we got our global equals, our global max equals the max between the current global max and current sum. So in this case, 0 can be a possible maximum. I will make this float minus infinity. So that way, when, whatever the first sum is, will be the current maximum. And then essentially return global max, right? Oh, syntax. Oops, I forgot the colon. Okay, test case. All right. Come on. 2. What? What are you talking about? How is it 2? How is that 2? What? Print. All right, every time. Okay, hang on. Print current sum. Print the current sum. The current sum. The current value plus the current value plus, so I got -2, -1, -4, 0, -1. Wait, what? At index 0, 1, 2, 3, 0, 1, 2, 3. So at 4 we have 0 as the total current sum. Then -1 becomes -1. Then we have 1. got 1, 2. Oh, wait. Huh. Interesting. What? All right. We're for looping through this. -2, 1, -3, 4, -2, 1. Let's see. The current sum is just what we're for looping through. So for num and nums, current sum plus equals num is the current sum. The global maximum. Okay, that's not what I expected to happen. Maximum subarray. Maximum subarray. -2, 1, -3, 4. -2 plus 1 is -1, right? Is this because... Oh, I see. Is this because it's not adding the value? So I see. If we actually have we could do something like this, right? Current sum could actually be... So it's the current sum at that position. Oh, okay. So we could do something like... Yeah, we could do something like... Okay, current sum is 0. Let's make it DP. DP array. A DP of... 0 times the length of nums, and then we can say as we for loop through it, current sum is this. So we want the current position in the DP array to essentially be the current sum, right? So current sum is what it is. So then we don't even need to keep track of the global, because that would mean... Oh, so then that means I would need I. Yeah, okay, I'll need I then. Equals current sum for num in nums. We can say something like for I. So the idea is that the current position in the DP array should be the current sum at that point, right? So let's see what happens. Oh, this is not going to return anything. Get rid of that for I in range, blah, blah, blah. Num is not defined. Oops. Nums I. Alrighty then. Okay, that's not what I expected. Oh, sorry, yeah. Plus equals. Sorry, wait, plus equals, or rather, the previous position. Oh yeah, okay, so that should be DP I -1 plus the current, right? Which means we need to start from 1, and the first index, this, well, then that means DP 0 equals nums 0, right? And then this should work. D is not defined. Oops. DP. What the fuck? Bruh, moment. Shouldn't this be... Why is it -1? Yeah, see, this position, this should be 6, but it's not. Yeah, index 0, 1, 2, 3, 4, 5. Oh, yeah, the screen is not showing it probably. Yeah, index 0, 1, 2, 3, 4, 5, 6. Basically, this index here should be 6, but it's not. Why is that the case? what am I doing wrong here? The first element is -2 because we start from 1. The current sum is the current element. So, or rather, actually, we don't even need the current sum, do we? Can we just say this? Fuck, what the fuck? The current position. So where we're saying, where we get here, this should be -1. That's correct. Then at this point, where we say -1 minus 3 is -4, then 0, right? Then, oh, wait a minute. It should be the current element. The current element plus the last. Yeah, it should be the current element plus the last element. Because so like for example, what the fuck? We start at -1. This being -1 is correct. Cool. This being -4, it should be -1 plus plus -3, which is -4. Then it should be -4 plus, oh, okay, -4 plus 4 is 0. Okay, I get it. Yeah, I see what you mean. Oops, okay. Okay. I know I kind of have the idea. I'm just kind of, okay. All right. -2. Gotta draw this down on notepad. I'm actually exhausted. I won't even lie to you. I need to get sleep, but I want to do this question. -2, 1. So if we have our DP array, our elements in it, the first element obviously should be, no, actually, yeah, the first element should be -2 because that is, first element should be -2. Obviously, that's the current maximum. Then at the next position, 1, and this is in the DP array, at the first index, right? We have 1 plus the current max. Sorry, the current sum, right? Current sum being -2. -2 plus 1 is -1, right? The current position -1. So, hang on. For I in range 1 to the length of nums, the current position in I in the DP array is the previous plus the current. It's clearly not correct. And do I not need to add the sums? Do I? I mean, if I say current sum plus the current element, so obviously, we're going, 0 minus 2 minus 1, same value, no? I mean, yeah, DP, I don't think we need this. The global maximum, however, is a situation. Actually, this shouldn't even matter at the moment. It's the building of this array. That's kind of weird. Well, if you think about it, if we're at the current position 1, right, this should be the current sum to this point. All right, let's think simpler. What do you need to do for one element? You have 1, for example, and you have our DP arrays, length of 1, 0, initial, actually it's 1, well actually let's say length of 2, so let's say it's 1 and 3, actually let's say 1, 3, and 5. So you have your DP arrays, the length of, let me draw this out here. So okay, so we have, let's say 1, 2, 1, 3 and minus 2, right? For example. Let's say that's what we have, for example, right? And take a thing here. We have 1. So we have our DP array should be length 3. So DP of length 3. 1, 2, 3. 0, 1, and 2. So the first thing in the DP should obviously be 1 because that's the maximum at the first thing. Then this position in the DP array should be the current current sum over here. So 4, right? So when we're here, the current sum is 4. Then take the max of DP at this moment. Actually, does that even matter? Actually, yeah. Take the max of DP at the moment, right? Which is 4. And then at this position, right? At this position, then we have a situation where the total sum, the total subarray over here. Okay, but wait, hang on. Forget the algorithm. Obviously, the largest thing is 1 and 3, right? Obviously. But at this position, we're saying if the current subarray allows for 4, then the next thing is minus 2. So you're saying the maximum subarray at 2, contiguous subarray at 2, is 2, right? The maximum subarray at 2 is 2, right? And then you just get the max of this thing here. No? Am I wrong? Is my logic wrong? This DP array is saying this is the current sum at this point. That makes sense, I think. Then at the second position, the maximum contiguous subarray at this point is 4. Then the maximum contiguous subarray at this point is, but then it's not really allowing for in between values though, is it? Maximum subarray. All right. The logic makes sense almost, but I can see where it's kind of lacking because at the second index, we're essentially saying that that's the current max you can get if you were to start from 1, but not the current max if you were to start from 1. Sorry, from 0. So, for example, yeah, cool. This represents the current contiguous subarray if you were to do 1, 3, and minus 2. But in the event that, for example, 3 and 2 minus 2 ended up being larger, so you had a situation of, I don't know, instead of 3, this was 7, right? So the result here, you know, this result here would end up being 5, obviously. And obviously 5 is bigger than 4. However, how do I get it so that it does that without running another for loop? There's got to be something I have to keep track of. I got to keep track of something. There's something I need to keep track of. Fuck my tongue. Ooh, bit my tongue. But yeah, there's clearly something I need to keep track of. How long has it been? 25 minutes. I'll give myself 5 more minutes. If I can't get it, then I'll look at the solution. That's how these are done. So hang on. If I'm at 5, then if I'm at 5, you know, like I said, imagine this was 7. Imagine this was 7 instead, right? And the result, you'd want it so that the result at that current position of the DP array represents the maximum it could be, right? Assuming all previous contiguous subarrays. So obviously 1 plus 7 is 8. Oh, obviously that would be a bigger number. But hang on. Wait a minute. Maybe 3 is not the best example to deal with. Maybe actually taking the actual array. Contiguous subarray. Alright. Maybe taking the actual number could be beneficial. So if we again look at it, what we have here is minus 2. Okay, so we got 0, 1. The effort actually 0, 1, 2, 3, 4, 5, 6, 7, 8. All right, we got 8. So we got a DP of 8. So 3, 4, 5, 6. Okay, so 1, 2, 3, 4, 5, 6, 7. Wait, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is 8. So 0, 1, 2, 3, 4, 5, 6, 7. Okay, so this is our DP array, and I'm saying I'm minus 2. At minus 2, what's the current sum? So obviously it's minus 2. That's all we got. Then we build on top of that, right? At minus 2 and 1, there's 3 contiguous subarrays here. There's minus 2 alone, there's 1 alone, and there's minus 2 and 1. Obviously, one way would be to for loop through it and then have 2 more for loops, so it would be cubed. But that would be quite a brute force method. But it would work. It would work, just very slowly. So if we're at minus 2 and 1, the current, I don't want to say current sum because, oh fuck, I can't think of the non-brute force method here. Minus 2 and 1. Minus 2 and 1. Obviously, we have a situation of what did it take to get to here, right? The subarray. So this is saying that the subarray at 0 is minus 2. That's the largest subarray at this position, right? This is the largest subarray at this position. So then what's bigger? This? Oh, I think I get it. So then what's bigger? This or them combined? So you're saying is the current subarray or the previous? So is the current element as its own subarray bigger than the previous maximum subarray? So what's bigger? Minus 2 or 1? Obviously 1 is bigger, right? Okay, I think I'm starting to get it. So if at 2, which is 0 and 2, so we're here. What's bigger? So the current, so the current. Oh, I think I get it, because now this index, this is saying of all possible combinations of subarrays, 1 is the biggest value right here. So then what's bigger? Minus 3 or 1? 1 is bigger, right? 1 is bigger. We then go to 4, right? What's the largest? So we know that at position, remember that we're at 3. So remember that at position 2, the largest, or rather, wait, 0, 1, 2, 3, wait, 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. Yeah. So this is, let me just fucking label it. I'm confusing myself here. 0, 1, 2, 3, 4, 5, 6, 7, 8. Wait, what? 8? Oh, there's 9 elements in this. Oh, then it needs an extra block at the end. Needs an extra block at the end, doesn't it? Alright. Oh. Look at these cool little tools. Alright, cool. So basically what it's saying is, what's this? Auto draw. Alright, so what it's saying is this. If we're at position 3, what's the current largest thing we can have here? The largest is, oh wait. Originally I said the current plus the largest previous subarray, but that means it's not contiguous because then I'd be saying 1 and 4. So the question then becomes, I know I'm on the right lines here. So the question becomes, okay, let's go from the beginning. The current subarray maximum we can have at the 0 index is whatever the element is, which is -2. So when we're starting our for loop, we always start at position 1, right? So we're asking ourselves, what's the maximum we can do here? Is it the previous maximum subarray at that index, or is it the current element as its own subarray? It's the current element here. We then move to -3. What's the biggest thing we can do here? Well, we see that the maximum subarray currently is still 1, so 1 goes to 2, right? Then we go to 4 and we ask the same set of questions. So then, what is the question we're asking ourselves though? We're asking ourselves the question of, is the current element larger than the previous, essentially? So then we plop it in, right? We plop it in. So we got 4. Then we're here. So then 4 minus 1. So at the 4 position, what is the largest subarray? Still 4. At this position, what's the largest subarray? As you can see, now we can do situation. Oh wait, fuck. Hang on. That doesn't make sense. I'm breaking the subarray things then. Let me go back. I'm definitely just kind of off maybe here. So we're saying at -2, the maximum is thing. And then at 1, we're asking ourselves the question, what's larger, right? The current element, is the current element larger? Is the current subarray as its own element larger? Or is the previous maximum larger, right? 1 is larger than -2, so we put 1 down. Then we go to -3. Let me ask ourselves, is -3 plus 1? Oh, I think we're asking ourselves this. Okay, I think we're asking ourselves, is the current element greater than the current plus the previous subarray, right? Plus the previous sub. So this is, I think, what the algorithm really is. We're saying, is the current element greater than the current plus the previous subarray sum, essentially, right? Okay. So then with that being said, is the current element, so is -3 larger than the current element plus the previous? It is not. So as a result, we put down, was it -3, 1, -3 plus 1. So the result then becomes 2, or do we put -3? Yeah, 2. So the largest subarray now is 2. Okay, cool, that makes sense. Sum-wise, that is. We then move to 4 and we ask ourselves a question. Is 4 plus 2, 6? Is 6 greater than 4? Or either way, just wait. Sorry, this might need to be switched, but essentially is 4 plus 2, which is the previous largest subarray so far, is 6 greater than the current? If so, we keep it. So 6, right? 4 plus 2. Then we go to the fourth index and we ask ourselves a question. So we ask ourselves the question again: Is minus 1 larger than minus 1 plus 6? It's not the case. So 5. So at this point, our current maximum subarray is 1 minus 3 plus 4, 6. So then we move on to 2. And we ask ourselves a question: Is 2 greater than 5 plus 2, 7? It's not, right? Oh wait, but now give us 7, which is not the largest. Hang on a minute. I'm on to something here, but it's off. I'm off with some kind of logic here. Hang on. Something here is a bit off. If I'm saying is 2 larger than them combined, keep the combination, then that would mean that... Oh wait, did I... No wait, shit, did I... Is this even the right index? Fuck, hang on. This is 4. This is 5. Wait, shit, hang on. Oh, I think I drew the wrong... I think I was putting it in the wrong index. Alright, so let me go back. Where was I? I was at 1. The current maximum at position 2 is wait, 1. What? No. Okay. Hang on a minute. At minus 2, the largest is minus 2. At 1, the largest is 1. Because we're asking ourselves, is 1 greater than 1 plus minus 2? It is. So it would make it 1. Okay, that makes sense. Then is minus 3 greater than minus 3 plus 1? This is position 2, right? Position 2. Is minus 3 greater than... it's obviously not. So it's minus... This should be minus... No, this should not be minus 2. Wait. Is minus 3 greater... Okay, so essentially, if minus 3 is... Okay, I think I get it. So if the current element is greater, then we add the... No, sorry. If the current element is greater... So the else scenario would be that you add them. So you add them and put in DP. Okay, this would be the else, essentially. Okay. So this is the else. That makes sense. Okay. Alright, so that's the else scenario. So then it's basically you do the opposite otherwise, right? Okay, so if the else scenario is add them and put it in DP, if it's smaller than. So if it's smaller than, you don't even need the else then. So if it's smaller than, just fuck it, add them up and put it in. So is minus 3 smaller than the current plus the previous? No. So we carry it over. So 1 gets carried over, right? Is 4 greater than 4 plus 1? It's not. So we don't add them up and put it in. Our new current becomes 4. Because at this point, this is larger than all the previous subarrays that you can have. All combinations here. Okay? And then at 5, wait, 4. Sorry, at 4, what kind of 4 is this? At 4, we're asking ourselves, Is minus 1 greater than 4 plus minus 1? It's not. So we carry the 4 because obviously it's 3. At 5 then, we're here. Is 2 greater than 2 plus 4? It's not. It's less than. And because it's less than, we add them together. So now we have a subarray that's this big so far. We then move forward again and we ask ourselves, is 1 plus 6 greater than is the current element greater than the combined? No. Add them together, but then that makes it 7. Shit, hang on. I feel like I have it, but because obviously that all makes sense. At 6, the current maximum subarray you could have is 6 because 4 minus 1 is 3. 3 plus 2 is 5, and then 6. So how is this getting 7? I'm definitely on some tracks here, and honestly, I would look at the solution, but I feel like I'm really close to getting it. So I kind of want to spend a bit more time on it. Let me go back to the beginning. Let me keep all this, and let me go back to the beginning, and let me start that all over again. Actually, no, I'm too lazy. That's too much effort. Okay. So, at the 0th index, we ask ourselves a question. Is the current element greater than all previous? Well, there's nothing there, so obviously it's minus 2. At 1, we ask ourselves a question at the first index. Is 1 greater than the previous maximum possible subarray sum? It is. It is. So, as a result, we take the one we start at that element. So 1 goes into it. Or does it? I mean, if 1 is greater, I said here if 1 is less than them combined. If 1 minus 2. So basically, is minus 2 and 1, which is minus 1. So is their combined thing greater than the current? Is the combined greater than the current? If these two combined is greater than the current itself, then obviously the current sum at 1 would be whatever that combination is. However, it's not. So, as a result, we put 1 here, right? Yeah, okay, yeah, sorry, it was less than. Yeah, okay, because I was the other way around. Okay, so then that means at 2 minus 3, we ask ourselves a question. We know that the current subarray at the first index, the maximum we can have is 1. So then we ask ourselves a question. Is minus 3, so if you started the subarray at minus 3, would that be larger than if you were to add the previous subarray to it, right? And then thus extending its contiguousness. So minus 3 is minus 3 plus 1, which is minus 2, greater than the current, right? Minus 3 plus 1 minus 2. Minus 2 is greater than minus 3. So as a result, since this is greater when they're combined, we then add them up and add it to the thing. So minus 3 minus 3, wait, sorry, 2. We're looking at over here. Yeah, so is minus 3. Yeah, okay. So it becomes minus 2, essentially. Yeah, that makes sense. So then at position 3, we ask ourselves, is the current element, so is them combined greater than the current element? Well, 4 minus 2 is 2, but 4 is greater. So we put 4 here. So then we go to -1. And we ask ourselves another question, right? Another question. We just love questions. We love asking ourselves these questions. Is them combined? Is these two combined for -1, 4, which is 3, sorry. Is 3 greater than the current element? Is 3 greater than the current element? It is. So we can go ahead and we can go ahead and add, sorry, oops. Yeah, so we can go ahead and combine them and add 3. Remember that what we're saying here is this is minus, so we're asking ourselves, is -1 plus 4, so is 3 greater than the current element? So we don't need to start it again. We can extend the array. We can extend the subarray. At 5, we ask ourselves another question. Is 2 plus 3, which is 5, greater than the current? It is. So as a result, we can extend the array again, and we get 5. We then ask the same question, and we get 6. Then we are at 7, and we ask ourselves a question. Is 6 plus -5, which is 1, greater than the current element? Is 1 greater than the current element, right? Is 1 greater than the current element? It is. As a result, we add them together, and we got 1. And then at the last position, we then ask ourselves a question again. Is 4 plus 1, remember that this at 7 is saying that this is the maximum possible we can have at 7, right? Or rather, the maximum is here, but it's more a question of at 7, after we've gotten our max, you know what I'm trying to say. But, I mean, the interviewer wouldn't, unless I explain it, but whatever. Point is, at 4, right? At 4, is the current element, is them combined together greater than the current element? It is. So we get 5. All right, so there's the algorithm. There's the algorithm, boys and girls. Let's program it. Let's go ahead and program this really quick, because we don't actually keep track of any of that. So yeah, okay. So yeah, for I in, well, I don't think I need i's here at any point. Nope, we don't. So we can just say for num in nums, if the current element, so if the current element plus, well, actually I will need to do that because I need to look at the previous DPI. So range 1 to the length of nums. So we're asking ourselves here, if the current element, well, actually, if the current element plus the previous in DPI is greater than the current element, then what did we say again? We said if it's greater than, then we add them up and put it in. So then DPI becomes plus equals DPI equals essentially these two added together, right? Okay. Else DPI just equals the current element. So we start a new subarray. So then we can return the max of the array, but then that would be, oh, okay, fuck it. But if I printed DP, you'd see that we'd have the, yeah, it makes sense. So then if I were to return the max of DP, this should work. Hey, there we go. Looking lit. However, it is slightly problematic because max here is not, this is an ON operation at this point. And I feel we could reduce things a tiny bit by I feel like we could slightly reduce things here just by a tiny bit. DP 0 length of nums. For I in range 1 length of nums. If nums I plus, yeah, it makes sense. But the issue then becomes, I don't like the way I don't like this here because it's an ON. 2 seconds. Yeah, I don't really like it there because, yeah, it works, but it is kind of problematic for the fact that we have. See, the issue becomes max is an ON operation, but there has to be a way to make it constant. I mean, the total runtime is ON, but you'd rather have just one ON rather than another thing doing ON, even if the whole thing is still ON. You could still make it faster. I mean, if I had like if I was keeping track of the current max at all points, right? So if I said like current max is the usual float minus infinity, float minus infinity. If I would said it was the typical shit, the typical minus infinity. And then at each point in the DP array, I could essentially just, well, I guess this could say current max. At each point in the DP array, we keep track of the current max, which is basically the max of the array at that point. That way we don't have to, we're only looping up to where it is at the moment. Or are we? Yeah, we should be. So we keep track of DP at this point, right? And then we essentially have a global max, all right? We can have a global max here. So we can say something like this. And then we can say global max equals the max between global max and current max. And then we can just return global max, right? Minus infinity. We can make that 0 actually, can't we? Wait, what? Global, okay, wait, global max, okay, the current max. Current max, well, yes, of course, the current max is the first element, of course. And the global max minus infinity, right? So if I had just 1 minus infinity, what? How would that even be the case if current max is the first element? If current max is the first element, current max is the max of DP here. I mean, would that even speed up it? Would that even speed it up either way? I mean, we're getting the max of DP at that moment. But I'm just gonna I'm gonna see. Actually, no. It seems that the solution I submitted just here is actually the fastest solution I've provided. Actually, maybe there isn't a way to make this any faster. I mean, I could definitely make it probably more memory efficient, but I don't really care about that. I think it's pretty good the way it is. Yeah, it's pretty fast. It's a fast solution. Yeah. What are other people saying about it anyway? Just out of curiosity. What are other people saying? Hot. Oops, wrong page. Discuss. Python 3 solution. That's pretty long. That's pretty long. That's a pretty long solution. Oh, that's newest. Hot. One-liner. Let's see. Of course, motherfucking one-liners. One-liners. I'm just I'm just looking for. I'm just kind of interested to see like what other people did in terms of, did they make it more optimal than mine or nah? Oh, okay. This guy keeps track. He's not DP. What the fuck is this? This is some pseudocode bullshit. Get the fuck out of here. Divide and conquer. Don't know shit about that. Who the fuck? Get the fuck out of here. Divine. What is that bullshit code? Jesus Christ. Let's still enter that fucking trash. Don't enter that trash. Ooh. Oh, this guy keeps track of. Alright, so this dude. Look at that. Yeah, that's pretty decent. O1 space, ON time. Oh, he keeps track of the current number plus previous. This dude is even in the F statement. Ah, that's interesting. This dude keeps previous max, which is the max of. Oh yeah, of course. What we're asking ourselves is, when we're saying is the current combination greater than the current element, we're asking ourselves, is that greater than that? So of course. That's where I basically just did a longer version of max here, but essentially, yeah, what we're asking ourselves is, that makes a lot of sense now. Yeah, so we have a current max is 0. Our global max is 0. Well, actually, sorry, that would still be, the usual flow infinity. The usual. Global max. It's a pretty good. I wouldn't say this is an easy question. If I'm being honest with you, I would not categorize this as easy. The fuck. But okay. Anyway, yeah. So essentially here, I'm saying what this line is essentially saying is this. Oh, what the fuck? Flash, get the fuck out of here. Anyway, what this line is essentially saying is current max equals the max between. So you can just do it without using the DP, so you get O1 space, right? And then we can just essentially say for num in nums, yeah, we can compare the current element to the current element plus the current max. Sorry, the current element plus the current max. Because you got to remember, current max in the DP array would have been whatever it is at that index, right? So this line is essentially saying this, really. So we literally don't even need this line here. We don't need to memorize it, essentially. And then instead of saying max of DP, you just keep track of the global max at all times, and then it only gets updated when obviously the value is higher than the current. Sorry, when the current max is higher than the global max is the only time that will get updated. So, yeah, then we can just return global max, essentially. And this should work. Looks good to me. Solid solution. Runs slower, though. Definitely does run slower, which is kind of weird. Saves on space. Oh no, yeah, of course LeetCode just doing his bullshit. Yeah, I think it was a good coding session today. Pretty good, decent coding session. I think I only wanted to answer one today, to be honest with you. Tired. I'm hungry. Got food waiting for me. So yeah, I'm gonna call it a day here. Just literally about to hit an hour in recording time, so I think solid hour of LeetCoding. You don't want to go too. Here's some advice, right, to myself really, because I'm not expecting him to watch this. I really don't expect, like, if you want to learn something, do bit by bit a day, right? Don't just try to cram everything in. Which is why I'm going over questions I've already saw, because I just kind of crammed it in 2 weeks. You know what I mean? I'm trying to give myself more time here. But yeah, cool. Looks all good to me. Looks all good to me. I think I'll keep doing easy questions for about another week or two, maybe until mid-December, before I take a flight to Turkey. I'll keep doing these, and then kind of late December I'll switch to doing medium only. But yeah, looks all good to me. Cool, 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 cool. Good day programming.